right? So this one x raised to x will be common, so x raised to x into bracket 1 upon x plus log x into bracket 1 plus log x. This is the answer of 1 upon y into dy by dx. So if we put y in the right hand side and then put the value of y here, then we will find the dy by dx. So dy by dx is equal to y into x raised to x and into this bracket, right? So in this way we can find the value of dy by dx. Here if you want to find in the form of x, then we need to put the value of y, and that is easily we can easily get the value of y from this one, okay, and put here that dy by dx is equal to y into x raised to x into bracket 1 upon x plus log x into 1 plus log x. So this one is the solution of second example of 3b. Now let us move to the third one. Our question is find the minimum or maximum value of the function f of x is equal to x into log x base e, right? So we need to find the maximum or minimum value. Here f of x is equal to, this is the third question, f of x is equal to x into log x, right? And first of all I want to remind you the steps to find the maximum or minimum value for any function. First of all we need to find f dash x, then we will find f double dash x. For the critical points f dash x is equal to 0, so if we put f dash x is equal to 0, then we will find value of x, then we will put that value of x in f double dash x to check the condition for the maximum and minimum, and from that we will decide that at that critical point function will be maximum or minimum. First of all here f dash x, that is equal to here x into log x, so again we will use the multiplication rule. So x into differentiation of log x, that is equal to 1 upon x plus log x differentiation of x, that is equal to 1, so into 1, so that will be 1 plus log x, that is equal to f dash x. Again f double dash x, that is equal to differentiation of 1, that is 0, and differentiation of log x, that is equal to 1 upon x. So this is the value of fx and f dash x and f double dash x. So now for the critical points we will take f dash x is equal to 0, right? So if we take f dash x is equal to 0, then 1 plus log x to the base e is equal to 0, so log x is equal to minus 1, so x is equal to, directly by the using the definition of logarithm, x is equal to e raised to minus 1, that means x is equal to 1 by e. X is equal to e raised to minus 1, that means x is equal to 1 by e, that is the critical point here. So x is equal to, implies x is equal to 1 by e. So now we will check the condition for the maximum or minimum. We will find, let f double dash 1 upon e, that is f double dash x, right? F double dash x is equal to 1 by x, so f double dash 1 upon e, that is equal to 1 upon e, that is equal to e, and e is strictly greater than 0, right? E is strictly, if f double dash x is greater than 0, then at that point function will be minimum. So we will write that at x is equal to 1 by e, y is equal to f of x, that is minimum. Okay, so at x is equal to 1 upon e, y is minimum, and the minimum value is, and minimum value is y is equal to f of 1 by e and f of x is equal to x log x. So x that is equal to 1 by e and log 1 by e that is equal to minus 1 by e, because here this one is equal to e raised to minus 1, right? So minus 1 will come out here, so that is minus 1 upon e, and log e base e that is equal to 1. So our answer will be minus 1 by e. This is the minimum value of this function, right? So we have our question is find maximum or minimum value for the function f of x is equal to x log x base e. So we have find the minimum value of the function which is at the point x is equal to 1 upon e, and the minimum value of the function that is equal to minus 1 upon e. So in this way we can find the maximum or minimum value for the any given function. Let us move to the question number 4. Question number 4a, that is for the integration, and the first one, that is integrate x cube 10 raised to 5 x raised to 4 into sec square x raised to 4 dx. So I want to tell you that here that is x raised to 4, that is x raised to 4, and here function is 10x, here that is sec square x. So if we take 10 x raised to 4 that is equal to t, then our question to integrate this function is quite easier. So let 10 x raised to 4 is equal to t, because differentiation of 10 that is x square that is available here, and the differentiation of x raised to 4 that is 4x cube, that is x cube also is available here. So that is quite easier to integrate in this way. So 10 x raised to 4 that is equal to t. So sec square differentiation of this one, that is sec square x raised to 4 into differentiation of x raised to 4 that is 4x cube into dx that is equal to dt. So x cube into sec square x raised to 4 into dx that is equal to dt upon 4, right? So that will be, so here we have x cube sec square x raised to 4 into dx. So we will put x cube into sec square x raised to 4 into dx, that is equal to dt upon 4, right? So our integration will be equal to, this one will be so integration this one that is equal to, directly I will write off here, so that is 10 raised to 5. Okay, so 10 raised to 5 that is equal to t raised to 5, because 10 x raised to 4 is equal to t, so 10 raised to 5 x raised to 4 that is equal to t raised to 5, and x cube into sec square x raised to 4 into dx that is equal to dt upon 4. So this one is equal to dt upon 4. Okay, so this one is equal to 1 by 4 t raised to 5 into dt that is equal to 1 by 4 t raised to 6 upon 6, okay, plus c, and again I will replace t raised to 6, t is equal to 10 x raised to 4, so this one is equal to 10 raised to 6 x raised to 4 plus c. So this is our required answer of integration. So 1 upon 24 10 raised to 6 x raised to 4 plus c, which is the integration of this function with respect to x. So by taking substitution at 10 x raised to 4 is equal to t, we can easily integrate this function. Okay, this is the solution of question number 4a. Let us move to the question number 2 of question 4a, that is integrate e raised to x into 1 plus x upon sine square x e raised to x into dx, right? So to integrate this function, as we have discussed in the last example, so we will use the method of substitution. Let us try to take x into e raised to x is equal to t, because this is the critical thing. So let x into e raised to x, that is equal to t. So we will get, by differentiating with respect to x, we will get, here we will use the rule of multiplication. So x as it is, differentiation of x e raised to x, that is e raised to x, plus e raised to x that as it is, and differentiation of x, that is equal to 1. So this one into dx is equal to dt. So if we take e raised to x common here, so e raised to x into bracket 1 plus x or x plus 1 into dx is equal to dt, which we have here, e raised to x into 1 plus x into dx, that is equal to dt. So now this one is equal to, this is dt, e raised to x into 1 plus x into dx, that is equal to dt upon sine square t. Okay, that is dt upon sine square t, right? So 1 upon sine square t, that is equal to cosec square t. So this one is equal to cosec square t, integration of cosec square t with respect to t, and integration of cosec square t, that is equal to minus cot t plus c, and if I replace the value of t, then cot x e raised to x plus c. This is the answer of integration. This is the quite easy method to evaluate the integration. This is the method of substitution, right? So if we put x into e raised to x is equal to t, so in this way we can integrate this function. Okay, so let us look at the last example of this session, because this session is going to end, and we have going to finish question number 4a, right? Which one is integration of sine 5x into sine 6x into dx. First of all, to evaluate this integration, we need to multiply by minus 2 and divide by minus, so this is minus 1 by 2 and minus 2 sine 5x into sine 6x dx, right? That is minus 2 ss, and minus 2 ss, that is equal to c minus c. So minus 1 by 2, this one is equal to c minus c, that is cos 11x minus cos, that is 6x minus 5x, that is equal to x, so that is c minus c, that is equal to minus 2 ss into dx. This one is equal to minus 1 by 2 integration of cos 11x, that is equal to sine 11x upon 11, right? And integration of cos x, that is equal to sin x plus c. So this one is the answer of our question, because integration of cos, that is sine, here coefficient of x, that is 11, so integration of cos 11x, that is sin 11x upon 11, minus integration of cos x, that is equal to sin x plus c, and minus 1/2, that is as it is. So this is the solution of this question, which is the third of question number 4a. So this is the end of question number 4a, and in the same we have going to end this session. So we have solved first 4 questions to the question 4A of the May-June 2014 Advanced Mathematics Group 2. So in next time we will going to solve question number 4B, question number 5A and question number 5B of this question paper. So that's it for this session. Thank you very much.